Dear students, welcome to our science episodes. Today we are going to discuss Universe and Solar System Part 1. Universe and Solar System. What is universe? What do you think? What is universe? Yes, it is the space which contains all the galaxies, stars, planets, moon, living organisms, and everything. Groups of stars are gathered in the universe to form galaxies. The Sun is one of the stars of our galaxy. Our galaxy is called Milky Way. Look at this picture. The universe is the wide, extended space. The wide and extended space that contains the galaxies. And the number of galaxies in the universe is about 100,000 million galaxies. These galaxies gather in clusters, including our galaxy, the Milky Way. The Milky Way contains the Sun and our solar system. The solar system is the Sun and the 8 planets revolving around it. The Earth is the planet where we live. The universe is incredibly huge, and no one knows the exact size of the universe because we cannot see its edge. Sun and Earth are parts of the universe, and there are, as I said before, about 100,000 millions of galaxies. What about our galaxy, the Milky Way galaxy? A galaxy is a collection of stars. It's a collection of stars and planets that are held together by gravity. A galaxy is the building unit of the universe. Each galaxy has a distinctive shape according to the grouping of the stars, and they are found in clusters of hundreds to thousands of galaxies that bound together by gravity. If you look at this picture, this is the Milky Way galaxy. The Milky Way galaxy that contains our solar system. It has a fixed center and 4 spiral arms. It's called Milky Way because it appears as a milky band of light in the sky. And stars are rotating in fixed orbits around a fixed center. Old-age stars are collected in the center of the galaxy, while the young ones are found on the spiral arms. Our solar system consists of the Sun and 8 planets revolving around the Sun. The Sun and the planets revolve around the center of the galaxy. So, you will find 8 planets revolving around the Sun, and the 8 planets and the Sun are all revolving around the center of our galaxy, of our Milky Way galaxy. It takes about 220 million years for the Sun to complete one rotation around the center of the galaxy. So now you can imagine the size of our galaxy when the Sun will take 220 million years to complete only one rotation. The solar system exists on one of the spiral arms of the Milky Way on the edge of the galaxy. And Earth is the planet of life in our galaxy. If we want to measure distances in space, we will use what is called the light year. A light year is the distance that light travels in space. And the speed of light is fixed in space. It's about 3 million kilometers per second. The light year is a unit of length used to express astronomical distances. And it's equal to about approximately 4.5 times 10 to the power 12 kilometers, or 5.8 trillion miles in a year. Here is a question for you. Distance in space is not measured by kilometers. Why? Because distances in space are extremely huge. Therefore, if it is measured in kilometers, the numbers will be too huge. Therefore, it cannot be measured by kilometers. That's why we are using the light year to measure distances in space. So, what is the origin of our universe? Since 1933, scientists believe that the universe emerged from a massive explosion. This massive explosion is called the Big Bang. 15,000 million years ago. They believed that before explosion, the universe was just a ball of gas of very high pressure and temperature. And through this Big Bang, the process of expansion and the change started and continues to this day. The atomic particles merged together, producing helium and hydrogen, galaxies and stars. So if you look at this picture, if we will say or assume that this is the massive explosion, Big Bang, after that, there was a process of expansion. This process of expansion started millions of years ago and continues to this day, where the atomic particles merged together, forming the helium, the hydrogen, the galaxies, and the stars. Within minutes after the massive explosion, the universe formed containing 75% hydrogen and 25% helium. And the temperature was about 10,000 million degrees. The universe expanded, and matter got joined in masses after 1,000 million years of the Big Bang. Ancestor galaxies were evolved within 2 to 3,000 million years of the Big Bang, and galaxies began to form after 3,000 million years after the Big Bang. Our galaxy, the Milky Way, took its disk form after 5,000 million years of the Big Bang. And the Sun was born after 10,000 million years, and then the Earth and planets were created. The earliest life forms began to appear on Earth after about 12,000 million years from the Big Bang. And today's universe formed 15,000 million years after the Big Bang. We discussed before together that the universe is in continuous expansion since the Big Bang and until this day, due to the movement of galaxies apart. So, one famous analogy to explain the expanding universe is imagining the universe like a loaf of raisin bread dough. So, if your mom or your grandma is baking, you can see the dough while the raisins are distributed in the dough. And then, after putting the dough to be baked in the oven, you will find that the bread or the dough will rise and expand. Then the raisin will move away from each other, but they are still stuck on the dough. That is exactly how the universe expands. This is a question for you. Give reason why the universe is in continuous expansion. Here is a question for you. Give reason why the universe is in continuous expansion. Yes, this is due to continuous movement of the galaxies. Let's fill in the blanks together. The two gases that resulted in formation of galaxies and stars over millions of years are, yes, hydrogen and helium. Number 2. What is the unit of length used to express astronomical distances? How do we measure distances in space? Yes, by using the light year. What is the building unit of the universe? A galaxy. Let's watch this video together.
This is our universe. The universe is everything we can see, touch, smell, or measure. It includes plants, planets, stars, dust clouds, light, time, and even objects which have not been discovered as yet. The universe is huge and infinite. It has no end. Our Earth is a very small part of this vast universe.
But how did the universe come into existence?
That is a very good question, Spiky. Scientists are also pondering over this question and have come up with a few theories regarding the origin of the universe. One of the most famous theories about the beginning of this universe is the Big Bang theory.
Is the Big Bang like a crash or a giant blast?
Yes, you guessed it right. Let's take a closer look at this theory. The Big Bang theory states that the universe started as a very hot and a very small ball of energy and matter, which is called the singularity. The singularity is an indefinitely small, hot area of infinite pressure and density. About 14 billion years ago, this singularity violently exploded. This explosion is called the Big Bang, and from this explosion, all matter, energy, space, and time were created. This is how the creation of the universe began.
But was there anything before the Big Bang?
Scientists believe that the Big Bang started from nothing. In other words, there was no space, no matter, no time, and no energy. Before the Big Bang, there was just emptiness. Atoms began to form as soon as the singularity exploded. After a period of time, the temperature dropped and clusters of stars called galaxies began to form. Some billion years later, planets began to be created, and an additional million years later, life started to evolve on the planet Earth.
What evidence supports the Big Bang theory?
There is some evidence that supports this theory. First, the scientist Edwin Hubble discovered that the universe is not static. Rather, it is expanding continuously. Galaxies are constantly moving further and further away from each other. Many scientists believe that these galaxies, which are moving away from each other, must originally have started from a single point in space in the distant past. Another evidence supporting the Big Bang theory is the detection of the cosmic microwave background radiations, or CMB. These are microwave rays assumed to be left over after the Big Bang. These radiations can be detected by using a radio telescope and TV antenna.
Dear students, thank you for watching. See you in other science episodes.